We're honored to have Mr. Rohith from Humans to Venus here with us today and uh, have you all join us for our discussion and presentation on Humans to Venus. Uh, Without further ado, here's Mr. Rohith Muhandan.
Amazing. Thank you so much, Cole. And yeah, thank you so much for all of you guys joining us today on a Saturday. I know you guys have your own plans, so we appreciate your time today, really. So, and yeah, amazing to kind of meet you guys as well. For those of you who have I've not kind of communicated with before, nice to kind of virtually meet you guys. Excited to be talking to you guys today about Venus, where we are with Venus in terms of exploration generally, where we are then in terms of the missions front as well, what we have to look forward to, and then also we'll close upon, what the Humans to Venus Foundation in particular is doing to kind of support that overarching mission. So if you guys have any questions, feel free to drop them in the chat. We'll also kind of close off earlier on so we can have a bit of a interactive discussion as well. So I'll aim to kind of wrap this up within, 30 minutes, and then we can have a bit of an open Q&A discussion. So I'll be curious to hear from you guys as well. But yeah, I think we'll make a start then. So in terms of myself, as Cole has introduced myself, I'll just give a brief overview of, my history. So I studied biochemistry at university, and I kind of figured out quite early on that I didn't want to pursue a lab type role as a career. And I also wanted to kind of work in the space sector that, it was in the space sector. And I think, it was difficult to kind of find access to the space sector kind of in the UK in particular, because there wasn't really much of a push in the UK. So what I did was I ended up becoming a management consultant full time. So I kind of done that for a couple of years. And then eventually started doing some cold networking on LinkedIn and all that kind of good stuff. And eventually came across the founder of the Humans to Venus Foundation, who is called Guillermo Online, who many of you will be familiar with. And then eventually he brought me on to be executive director of this company, which is a non-profit organization. We're currently based out of Atlanta, Georgia, which is where Guillermo is, predominantly based from. But our leadership team is, spanning globally as well. So we'll kind of go through just the details of that near the end of the presentation. But in terms of today, then, so a question I want you to pose to you guys as well, just to kind of like as we go through this presentation. So, what would it take for 1,000 people in the Venusian atmosphere to be sustained in a habitat? Let me just make sure I can shift screens here. So, yeah, what would it take to set up and sustain a 1,000 people Venusian community? So keep this question in the back of your minds. You may have a few ideas as we go through the presentation, but yeah, and we'll kind of come back and address this at the end and see if you guys have any ideas or any thoughts have been stimulated from this presentation, which hopefully they would be. Um, but yeah, we'll go into the beginning then. So in terms of today's presentation, I've broken it down to three key parts, right? So the first is going to cover, why Venus, why we're tackling Venus, why we're choosing to pursue Venus in particular. The second will be, focus on the missions to Venus, so past missions, upcoming missions, and private missions as well. And then also the third part will be just an overview of the Humans to Venus Foundation, like we covered before. So, with that being said, we can go into the first part of today's presentation. So, why Venus? Why are we even considering Venus when we have the Moon and Mars, which Elon is already pursuing, right? Is there even a need to do so? So, in terms of Venus, right? So, I know many of you would have heard the term hell planet thrown around in terms of describing Venus, right? And that is pretty much a very accurate, accurately determined name, given the fact that, the surface of Venus is 450 degrees Celsius, and it boasts 90 bars of atmospheric pressure, right? So that is essentially, inhospitable, right? You'd never find any form of life on the surface of Venus, and would never, imagine to survive in terms of a human habitation on the surface of Venus. So that is completely written off in terms of, our pursuits. But it gets interesting when we kind of elevate above the surface around 50 to 60 kilometers, roughly in the 55-kilometer region in the atmosphere of Venus. We have some very, presentable and Earth-like traits that we've discovered really. So essentially the first and the most, arguably the most important trait, which you can see on the screen there, is gravity. And gravity at approximately 55 kilometers above the Venusian surface is roughly 1 G. It's actually zero point 0.9 Gs, but it's very similar to what we experience here on Earth in everyday life, right? So the fact that we don't actually understand much about gravity in general in the space sector, right? How to kind of artificially simulate gravity, and how to kind of do that on a larger scale if we're talking about human habitation on a permanent basis. And the fact that we have this 1G of gravity roughly presented to us, naturally occurring in the solar system is, reason enough just to go and explore the atmosphere of Venus and see if it's viable in the future for us to even set up a base in that atmosphere region for human habitation in the future. So, if we're talking about numbers, right? So if you weighed 100 kgs on Earth, for example, you'd only weigh you'd weigh similar on in the Venusian atmosphere, roughly 90 kgs if it's zero point 0.9 Gs, right? So there won't be much to do in terms of offsetting the gravity or kind of artificially simulating the gravity. You would experience something similar to what you do here on Earth, which is amazing. The second is radiation protection, right? So in terms of radiation protection, it is similar to Earth as well within the Venusian atmosphere, but it's not in the way that you might think. So essentially, the way it happens is as the sun, bombards the planet with UV light, that UV light essentially excites the ions in the atmosphere of Venus, and that actually forms a bit of an ionosphere, whereby all of the magnetic fields from the sun interact with these excited ions, and then it kind of shields the radiation around the planet in a kind of like a teardrop manner, and it kind of like just evades the entire planet. So we're actually protected from the radiation from the sun because of this interesting mechanism and the ionosphere. So that will essentially help us in terms of surviving the atmosphere, obviously. The third reason is pressure is almost, 1 atm, which is similar to what we experience here on Earth at sea level. So again, in the atmosphere of Venus, it's 1 atm, whereas on the surface, it's 90 atm, right? Which is significantly higher. So we're kind of focusing on the atmospheric area for human habitation in the future, anyway. And then finally, temperature is roughly in the 25 degrees to 50 degrees Celsius range, which is, the region of liquid water, which is again crucial, right? So the fact that again naturally exists is reason enough for us to go out and at least explore, send some data, reconnaissance missions out there and understand more in more detail if this is a viable location for humans to survive on in the future, or at least off planet, right? So yeah, I mean, these are very appealing traits, but we also have a few additional traits to consider as well. So one is proximity to Earth. I mean, Venus is, the closest planetary neighbor to Earth, which is amazing as well in terms of launch windows and how often we can send up, payloads to Venus and back. There are much more opportunities to do so with Venus as opposed to Mars, in particular. So yeah, that is a very interesting trait. And then also it is known as the sister planet to Earth just because of the similar, you know, um, physical traits that Venus exhibits in terms of size, mass, gravity, and we'll come on to that in the next slide. But it is a very much a similar planet to Earth. And yeah, it's a lot of positives that we see on the screen here, right? So what are the detractions of actually surviving in the Venusian atmosphere? Because there must be some, right? And you are right, there are some. The main detractions of targeting Venus are there's two in particular. The first is that the atmosphere is predominantly composed of carbon dioxide, and then also the clouds are mostly sulfuric acid as well. So again, these are very toxic substances, but these obstacles can be overcome with the technologies that we have available to us in modern day, right? So we have acid-resistant materials that we can use to build these habitations if we were to go out there, and then also we have breathing apparatus as well that we can use if we needed to use that. In the atmosphere as well. So we can bypass these two main detractions with technologies that we have today and now. So instead of, why Venus, the question would be, why not Venus in our eyes? So yeah, in terms of how we're kind of proposing that. So again, on screen here, you can see a bit of the similarities of Venus and the Earth, in terms of mass, distance from the sun, atmospheric composition. Obviously people, we have 7.9 billion people on Earth, zero on the Venusian atmosphere for now, anyway. But we're pushing for roughly around 2050. We're kind of aiming to have as a long-term vision for the Human Venus Foundation, alongside the other things that we're doing, aiming to have, roughly 1,000 people situated living inside the Venusian atmosphere if it proves to be a viable target from all the research that we do in the years from now in the kind of coming decades, right? So it's something we need to kind of investigate further, but the theory makes sense, the theory works. It's more about testing that now in the coming years. So it's going to be very exciting for the space sector, for Venus in the coming years. So it'll be good to kind of keep your eyes peeled about anything that is upcoming there in terms of missions. In terms of some interesting questions that we address when we are talking about Venus, right? So these are some common questions that we get, and you can find these on our website as well with the answers if you're kind of curious to find out more, along with some other questions. But these are the most common questions that we get when we're talking about Venus. So the first of these is, what is the surface of Venus like? As we established before, We've partially touched on this, right? So it's 450 degrees Celsius, 90 bars of atmospheric pressure. So in terms of life as we know it, it wouldn't be able to survive on the surface of Venus, and it's not something we're pursuing. It's completely inhospitable. The surface of Venus is actually covered in volcanic terrain with large shield volcanoes, lava plains, and impact craters as well, which many of you may have known from recent images that have been shared as well. Recent studies have also suggested that this is still ongoing in terms of volcanic activity as well. So it's something that it's a very fluid surface of Venus in terms of the tectonics and the activity of Venus. And we have a few scientists in NASA working on the specifics of the surface and how the tectonics move around and the volcanism of the surface of Venus. So there's a lot of data that needs to be obtained in terms of how we, picture the surface of Venus because we do know very little in the grand scheme of things compared to Mars and the Moon, for example, right? So there is a lot more to be done in terms of data gathering. And in terms of, why we're pursuing Venus as opposed to Mars and the Moon, right? So, Elon is always, pushing for Mars. He's done so for a while now, right? So 2050, he's aiming to have long term, 1 million people situated underground on Mars's surface, right? So why are we focused so much on Mars and the Moon and not Venus? And the reason for that is simply that humanity is used to historically, if we look back, right, in terms of our previous missions, we're used to landing on the ground, putting a flag down, having a boots and ground experience, and saying, we've landed here. And that opportunity simply isn't available with Venus if we're talking about the atmosphere, right? It's a very novel concept. It's a bit of a sci-fi concept when you kind of like hear it for the first time, but when you understand the science of it, it does make sense. And it's something that just isn't as commercially viable as, Mars and landing on Mars because it's just been ingrained into society for so many decades now, right? So it's been a goal since, the 1980s, if not before that, right? So it's just something that needs to be done commercially. And if we're talking about NASA as well, taxpayer money and all that kind of thing, right? It kind of makes sense to have a commercial narrative that is kind of looking towards that. So what we're kind of doing is we're proposing Venus to be done in parallel to the Moon and Mars. We're not saying by any means, to go to Venus and, forget about Mars, forget about the Moon. We're just saying doing this, do Venus in parallel to doing the Moon and Mars. The technologies that you'll be using to go to the Moon and to go to Mars make sense chronologically, right? So when you kind of go to the Moon, it makes sense that the technologies will be transferable to actually get to Mars as well. Whereas, the technologies used for surviving on Mars and the Moon are completely, irrelevant for the Venusian pursuit as well, right? So we need to be doing we need to be doing this completely separately. And most likely it's going to be done privately unless we get some kind of uptake from one of the space agencies to kind of do missions as well. But it will be mostly privately funded, which will obviously allow it to be done quicker as well. So yeah, that's the first question. Second question, is there life on Venus? So this is a very interesting question. To put it simply, we don't know so far. We don't know definitively, but there are indications, right? So there's been a recent study that has demonstrated the presence of phosphine gas in the atmosphere of Venus. And for those of you who don't know, phosphine gas is usually an indicator of microbial life. So the fact that there is a presence of this inside the atmosphere of Venus is very exciting because it could present the opportunity that there is microbial life surviving inside the atmosphere of Venus. And if that is the case, that could be the first indication of life off Earth, right? So that is a amazing prospect. So again, more studies need to be done to confirm that. But this is something that Sarah Seeger is working on, Professor Sarah Seeger from MIT, with the Rocket Lab mission, the Venus Life Finder mission, which is going to be aiming to launch, I think, in 2028-ish, or maybe even actually 2026. We'll come on to that in the later slides in the presentation. But they're looking to launch soon and kind of confirm that data and those observations, which will be very interesting. How long is the Venusian day and year? So this is a fun fact, and I'd arguably say this is one of the funnest facts, the most fun facts that I've kind of come across, kind of getting into the Venus space. So Venus actually rotates on its axis extremely slowly, right? So it makes its day as long as 243 Earth days, which is very long. We talk about time on the and how we know time and how we process time, right? On the other hand, it rotates around the sun very quickly. So that actually makes its year longer than its actual day. So its day is roughly equal to 225 Earth days, whereas its year is 243 Earth days, just because of the rotation on the axis versus the rotation around the sun. So that is an interesting fact. Again, if we were to survive in the evolution atmosphere, the concepts of time and how we kind of do time, given days and years and how we're used to doing things on Earth would have to be adjusted, and if not artificially simulated to kind of like, initially simulate Earth-like environments inside the atmosphere of Venus. But again, these are questions that need to be addressed. We're still very early stages right now, but these are the kind of questions that we're posing to professionals, people who are working inside the space to understand that in more details. But yeah, how long does it take to travel to Venus? So roughly, in terms of just getting from Venus to Earth, it will take you roughly 5 months one way to reach the planet. I think it's roughly around 7 months for Mars. And obviously with Mars, there are a lot fewer launch windows of opportunity to kind of go to Mars, right, compared to Venus, just because it's closer. So yeah, 5 months one way to reach Venus. In terms of the key risks of living inside the Venusian atmosphere, we've covered this again already, but it's going to be the sulfuric acid clouds and then also the carbon dioxide in the atmosphere. And then in terms of human spaceflight, how are Venus and Mars different? So we kind of touched on these again, roughly, but it's worth mentioning that Venus is much closer to Earth than Mars is, which means that, there are much more launch windows, which is the key thing, and also shorter transit times as well. So in turn, this minimizes the risk of cruise exposure to microgravity and solar radiation, as well as reducing the overall cost of the mission. So yeah, those are some very interesting questions, common questions that we get asked about Venus in particular. And that concludes part one of this presentation. And I know that there's been a bit of a comment on the chat there. I can't see what the comment is. So Cole, I may ask you to quickly let me know what the comment is, or if anyone wants to come off mute and ask a question, by all means do so. We'll be happy to kind of hear your thoughts as well. So I'll pause there quickly. Any questions in the chat, or should we move on? I did see the chat notification go off, but I can't really see what the comment or question was. But if nobody comes off mute, then that's fine as well. We can also go forward.
We was just mentioning sometimes 3 to 4 months one way to
Okay,
Venus is attainable too.
amazing. Cool. So that is part one of the presentation then. So that is just general FAQs about Venus, in particular, some cool facts as well. So in terms of missions to Venus then for part two, so we've had roughly more than around 40 spacecraft that have launched to Venus to date. And of those 40, around 31 have been successfully, actually gone to Venus, actually reached Venus. So I'm going to focus just now on the successful missions as opposed to the ones that have failed. And those, done by the relevant nations as well. So you can see roughly the distribution of how these missions to Venus have been, done over the past decades and years, right? So in terms of the beginning, let's start with the USA. So in terms of the USA, you can obviously see from this timeline from 1962 to 2018, there have been 9 successful missions to Venus, including flybys, orbiters, and one impact mission as well. It's also worth noting that NASA's Mariner 2 was the first spacecraft to visit any planet beyond Earth when it flew past Venus on December 14th of 1962. So the data gathered in a 42-minute, scan by Mariner 2 first revealed to us that Venus has a runaway greenhouse effect, again, which is a very relevant thing to know about, right? Because it's, arguably, in the distant past, Venus had very Earth-like conditions, but it ended up, having this greenhouse runaway effect and, leading to it becoming the whole planet that it is right now, right? And how it's been branded. So are there lessons that we can learn from Venus and how it's transitioned from its journey in the past to the future to where we are now and where it's going? Compared to where Earth is going currently, what we're experiencing with climate, climate crises, et cetera, et cetera. So there are going to be lessons that we can learn, and all the more reason to send more probes out to Venus and understand in more detail, what the atmosphere is composed of, what the surface is like, how Venus operates in general. But yeah, looking to the future, it's important for us to understand that in more detail. In terms of the Pioneer Venus missions of 1978, you can see on screen there as well. So that consisted of 4 atmospheric probes and one orbiter. 3 of those atmospheric probes made it to the surface of Venus, successfully probing the atmosphere on their way down. And one of these probes actually broadcast for around an hour, which was an indication that we could actually land and function on the Venusian surface. And that was a really impressive milestone in general, because obviously, the harsh conditions when you go lower and more towards the surface does not allow or does not allow for probes to be kind of surviving for more than an hour, if that, right? So the fact that we have that data is really impressive, but it shows it can be done, which is the main thing, right? And we can always improve the way that we do things, the way we kind of improve our technologies and how we've shaped these drones and these missions as well. So that was a very, very pivotal mission, I would say. In terms of this slide here, there's a few select images taken from the US missions to Venus. Some very cool images you can see there. So the first almost Earth-like image you can see there, it was taken from the Marina 10's UV filter. And that was actually color enhanced. So that's not actually the real color. It was color enhanced to kind of visualize the clouds in Venus, right? It's in more detail. The second picture you can see on screen there is a hemispheric view of Venus, centered on the North Pole. And that was revealed from over a decade of radar investigations compiled together. And that was also from the Magellan missions, which took place between 1990 and 1994. And again, it's been color coded to kind of indicate, the areas of elevation. So areas of red are high elevation, blue, green, lower areas of elevation, right? So that, again, that gives us more understanding of how the surface of Venus and the tectonics are kind of situated and shaped, right? So again, very important data to understand if we're trying to pursue Venus in general, and general for, generally for science as well, right? So very, very interesting pictures here. And then also on the right there, you can see a very cool video there, a quick clip of the Parker Solar Probe as it passed Venus during its fourth flyby. And that's actually the night side of Venus. So very, very cool that we have footage of that as well. And yeah, and as you can see, this is USSR, so Russia, right? So you can see here compared to the US, if we go back a couple of slides, we have 9 missions here versus 17 for Russia, right? So obviously when we talk about Venus missions, Russia are pretty much the leaders in the field in terms of the data they've obtained from all of these missions to Venus. They have the most data. So if we're talking about the future of Venus, space being a global frontier and all of that, we do need to kind of figure out ways in which we can collaborate with Russia and kind of get access to these data that they've gathered over all of these missions because they have a multitude of missions that they've launched over the past de few decades, right? So the real stars of the show here are the Venera missions there. You can see there's multiple Venera missions on screen there, and these are pretty much just industry grade, metal containers that kind of drop down and simply hold out against the immense pressure of going down towards the surface of Venus, and the 90 bars of atmospheric pressure, right? So the longest any spacecraft has survived on the surface of Venus is as little as 2 hours. That was the record set by the Venera 13 probe in 1981 there. So you can see the sheer number of Venus missions, sheer number of missions in general, Venera missions, 16 of those in total. So the Soviet Union really is the leader in this field and are leading by example. And they have got a few more missions planned as well, which we'll come into in the future. But again, the key is going to be sharing the data and kind of understanding how we can collaborate with other global space agencies to kind of obtain all of the data that we have so far to make sure that we, understand as much as we can before we pursue it. So here are some beautiful panoramic images. Some of the my most favorite images from Venus. I mean, they're actually the only two images from the surface of Venus. And these were panoramic images taken from the surface of the Venera 14 probe that was sent down in 1982. And as you can see, they've revealed very yellow Earth-like kind of dystopian landscapes, right? It kind of looks Earth-like, like some kind of a desert, but it's also very alien at the same time. So it's almost as if it's a world that's kind of like, it once had life or once was like Earth, but it's actually just had a bit of a phase where it's just turned into this alien-like planet, right? So again, it's a harrowing reminder to us that we need to understand more about what's happening on Venus to understand, how we can transfer that, any kind of transferability to what we're experiencing here on Earth as well, as we established before. And it's not just about, escaping Earth and going out to Venus, to get to the moon, to Mars, and beyond. It's actually learning about going out there, but then also understanding how those problems and how the data we obtain from, these missions can actually help us to support with the issues that we're experiencing here on Earth as well. So it's not just about going out there and leaving Earth behind. It's about going out there and understanding answers, understanding more about science, so that we can actually implement those on Earth as well. So those are the main things, and those are the main reasons I think that science needs to be pursued in more detail. There needs to be more budgeting allowed for more Venus, Venus missions and Mars missions, et cetera, right? All of these missions help with our understanding of Earth and how our understanding of survival, functions as well. So yeah, moving back onto topic. So in terms of outside of the USA and the USSR, we have ESA and Japan as well, so JAXA. So much fewer missions to Venus to date, but it's still good that we're having these missions, right? So you can see there from 2005 to 2018, there's quite a few missions there that have been done from ESA and JAXA as well. The Akatsuki orbiter launched in 2010 is currently still orbiting, I think, Venus to this day. and it's looking into the investigating the climate of Venus in particular, which is very interesting, right? So all of these missions will be kind of investigating a different aspect, a different facet of Venus that we don't understand, to a considerable amount of detail. And again, all of these help us to form a more consolidated view of Venus and our understanding of Venus. And then, yeah, a couple of images again from those missions. So you can see on the left, a false color image of the night side of Venus captured by the Akatsuki infrared camera. And then on the right there, you can see an image taken by ESA's Venus Express showing the spiral clouds in the southern hemisphere at around 55 kilometers. So with that, we have summarized, I guess, the past missions, successful missions to Venus to the present day. What missions do we have to look forward to in the future, in the coming years? So again, I'm sure many of you would know there are, it's quite a tough political landscape at the moment, especially in the US. But these are six upcoming missions that we have, to look forward to in the near-term future, in the next couple of decades at least, anyway. So starting from the left, we have the UAE's interplanetary mission. So that will be taking place roughly in 2028. It'll be a flyby mission. And the purpose of that mission in particular is to explore the asteroid belt between Mars and Jupiter, which is the source of most meteorites that impact Earth. And that will be done through a Venus orbit as well. So there'll be some data and some images taken during that orbit, which will be interesting. And yeah, 2828 is not too far away. So again, we can look forward to that in the future. In terms of India, so Shukrayaan 1 is expected to launch in roughly 2028. It's an orbiter mission aimed to investigate Venus's geological and volcanic activity, emissions on the ground, wind speed, cloud cover, and then other planetary characteristics from an elliptical orbit. So again, crucial data, right, that we need to obtain, and quite, nearby in the future as well. So 2028 is looking like a very good year for Venus, in particular, if these dates stick, and hopefully they do. And then yeah, Da Vinci is a USA mission, obviously. But with the USA, obviously, with budgeting issues, et cetera, NASA's budget has been slashed significantly recently. So it's looking tough, but hopefully we're looking to have that launch in around 2029 currently, and it's going to be an orbiter mission, atmospheric probe mission as well, primarily to investigate the atmosphere of Venus with connection to the local surface in the mountains. So this will be very, very relevant to our understanding from a human to Venus perspective, understanding the atmosphere in more detail and how that is structured and how having a habitational structure inside the atmosphere would work in terms of feasibility, right? So that would be a very crucial mission. Um, Envision is an ESA organized mission. That would be an orbiter mission, again, looking for a launch roughly in around 2031 at the moment. And that one will be focused on studying the volcanic gases in the atmosphere surface interactions, again, similar to Da Vinci, and then also surface compositions with the interior structure of Venus. And that will also return some high resolution radar images of the surface. So similar to what we saw before, but in more detail. So that will be very interesting to see as well, just how Venus's surface is structured in more beautiful imagery. So that would be very nice in terms of just understanding how Venus looks like in our eyes, right? So that's Envision 2031 launch. Veritas, again, is another USA mission. Again, same kind of issues they're experiencing with budgeting and NASA budget slashes, but they're proposing to launch in roughly 2031 so far. That is an orbiter mission. So that was going to be primarily investigating the global surface and the interior of Venus in particular. And then also Venera D. So that's from the Russian Federation, orbiter lander mission. This is something we don't know much about as much as the other ones, just because there's sensitivity around the politics and all that kind of thing, right? But from what we can understand, they're roughly aiming for a 2034 launch. Again, that's TBC. But the goal of that mission is to study the surface of Venus again, the atmosphere of Venus, and then also the internal composition, right? So you can see from just those six missions, if we send those out there, we'll get a multitude of amazing data that we can combine together. And this is why the pursuit of Venus needs to be a global effort as opposed to individual agencies doing their own thing, right? So all of the data that's going to be obtained from these missions needs to be combined together so we have a single source of, as much as we know about these as possible. And that will help us to, fund future missions and understand how to plan those missions in the future. So yeah, breaking down those barriers will be a very key mission from the human civilians perspective in the coming years to understand more about how we find a more of a single source of Venus today. So in terms of private missions to Venus, then this is where it gets exciting, right? So we have a very near-term vision, a mission coming up from Rocket Lab and MIT in collaboration. So as we mentioned before, the study and the identification of phosphine gas in the atmosphere, right? So that was a study that was kind of obtained, and the data was obtained by Sarah Seeger at MIT. And they're kind of collaborating with Rocket Lab to send out this private mission. It will be an atmospheric probe mission, currently launching roughly, they're aiming to do this in 2026, so next year, very, very soon. And the goal is to catalog the molecules in Venusian clouds to determine whether there are any organic, molecules in the atmosphere of Venus, which could be a possible indication of life. So confirming those initial observations, and making sure that those are reliable. So that will be a very exciting mission. And again, the prospects of that becoming, being confirmed are groundbreaking, right? Just generally in terms of science and the pursuit of Venus and life outside of Earth itself. So you can see on screen that the small probe that will be dropped in, that's the photon probe that will be dropped into the atmosphere to collect all of that data. And then there's also a representation of the Rocket Lab photon spacecraft, which the probe will come out of and drop down into the atmosphere of as well. So cool imagery there, and that is I guess the nearest term private mission that we have coming up to Venus. So yeah, that's something we can look forward to next year, and hopefully there'll be no postponements or delays with this one. And then yeah, this is part two concluded. So I'm going to pause there again because I know the chat was going. There were a few comments in the chat, right? So Cole, I'm going to ask you to come off mute again if that's okay. And just if there are any questions, feel free to come off mute as well, and we can discuss those. But hopefully that gives you a bit of an overview of the missions to Venus to date, where we are in the future, and what we have to look forward to as well. So I'll pause there, and please come off mute if you have any questions. I'll be happy to kind of answer those and address those as well. So yeah.
Amazing. Thanks so much, Ro. This is very exciting. We've got 2 minutes here for a Q&A and discussion.
Amazing. Any kind of questions in the chat call that we need to be answered or anything posed that will be worth addressing? Or shall we move on?
Um, I did have a question uh, to we may consider wondering how and when humans to Venus may support a you know our own uh, private mission to Venus.
It's a great question. So, in terms of the Human Venus Foundation, I'll come on to this in the final part of this presentation, right? So, what we kind of actually do, we are a non-profit, so we're not going to be involved in actually formulating the missions in particular. Our job is more to bring together the people who are working inside these space agencies, who are working in the science, to bring them together and then actually kind of shape a mission together, right? So it is pretty much a connecting the dots situation, and that's the main thing. As we established before, there are many silos in the space sector, right? Which I'm sure you know, Cole. Yes, people work in their own kind of like labs, their own kind of like industries and their own kind of areas, and there's not really much of a data sharing situation going on. So I think bringing those people together so they understand, exactly what's going on, so they can actually better inform the preparation of these missions is what we're going to be doing from the foundational perspective. But I guess we are working with underwriting a mission, a crewed flyby to Venus in the future. I can't really say too much in terms of details right now, just because it's very confidential at the moment. But in the near term future, we are planning to kind of work with a few exciting companies to send up some payloads to Venus, have a bit of interesting studies as well. More will be revealed in the coming months and years, but we are in the planning phases of that. But we are kind of working towards, bringing the right people together to kind of have those missions planned and sent out in the future and obtain the funding for those missions and make sure that they're not just visions, but they're actually things that we can manifest and actually happen in the future. So there will be some exciting things happening, but yeah, we'll have to be holding off on the details of those for now.